So, our third and final speaker for the day is Geoff Ballinger, Head of Platform Machines with Vision. And I had a bit of a chat with him about this before, and it's to do with trains. Geoff, over to you.
So now for something a little different to help finish off our day. Hopefully, so if it feels like this is a bit different from cloud things initially, please bear with me, we will get to cloud. So I'm Geoff Ballinger, I'm Head of Platform for Machines with Vision. We provide the rail industry with highly accurate machine vision-based mobile sensor data mapping, which probably doesn't mean much in one sentence, but we try to with one sentence. The problem they have is they gather data on measurement trains, think rough ride data, overhead line data, all kinds of different bits of data you might want them to look at to make sure the trains don't break. And they do that repeatedly on multiple trains over multiple runs. But those data sets can't be aligned automatically. You can do it manually, but that isn't tractable at scale. So you can't automatically get progression over time at a particular location. And that's a bit of a problem they've got. So we try and solve that problem for them. I'm not going to read all the stuff on this slide, but there's interesting bits up there if you're in for the technologies. But we essentially deploy novel machine vision-based technology based on downward-facing event cameras pointing down at the rail bed to maintain an image-based model of the railway, which you can then use to align those runs. If the one thing I will pick out is event cameras, because I think they're fun. If you're into tech, maybe you do too. They are asynchronous cameras. Every pixel works asynchronously. There's no frames being taken from the camera. Each pixel, when it goes past the threshold, either up or down, generates an event, and you get a stream of events. So they're great when you're pointing down at the ground at 150 miles per hour, which tends to happen on trains. So the system we deploy consists of some kit on the train, those cameras, also has IMUs, all the usual things for a navigation system, GNSS. We're also computing visual odometry on the train. That's all happening in a shiny box we attach to the bottom of the train, which doesn't stay shiny for very long. We then have some clever algorithms. We run the cloud, which takes all that data and computes the location of the train to a very, very high degree of accuracy. And all talking of cloud then is a cloud platform where we draw that together and allow our customers to align the data they've pulled from the trains using our system. So that's what we've got. In a bit of reality of it, this is one of our initial systems, which is deployed on Deutsche Bahn's Rail Lab 3. It was quite a big centre we had at that time. One thing I'll say as an aside is I've been spending an awful lot of time in pits under trains for the last few years. It's been a bit of a change from my previous career in mobile and media and things like that. A bit closer to home, here's one of our systems, a more recent system on a ScotRail Class 158. If you look out around the trains that are passing by you in Scotland at the moment, we've got 4 of these vehicles running. Look for the ones that glow in the dark. They're our trains. So, all great fun. Why am I talking about this in a cloud conference? Currently, your rail navigation systems, which you might use to solve this kind of problem, they are entirely run on vehicle. We do things a bit differently. They're run on vehicle because there's an assumption in a lot of their designs that you need a low latency feed of accurate location on the vehicle itself. But actually, for the infrastructure, data alignment infrastructure monitoring use case, that's not true. We solve for location in the cloud. Because we're working on post-process data alignment, it doesn't matter so much that latency. We've got that advantage. So we've got the kit on the vehicle, GNSS, IMUs, visual features from the cameras, odometry, and that's all flowing up over 4G into the cloud, where we maintain our central model of the railway itself on our cloud system. The advantage of doing it in cloud is you can solve over much longer periods of time to try and work out where your location of your vehicle was. You've got somewhat less constrained compute. Getting stuff onto trains is hard, particularly they're quite twitchy about power use and things like that, particularly on passenger vehicles. And that allows us to get that improved accuracy so that we're not wandering around by meters, which doesn't help you very much. We're getting it down to centimeters, which is what they need. That has some challenges, though. And we have to live with these challenges. The one fundamental is that 4G on a Scottish railway around the north of the Highlands is not great from time to time. You've got to buffer the data coming up into your cloud. You've got to have very, very robust upload logic, because if anybody's done much network engineering here, every failure you've ever seen will be happening every hour or so on one of these transfers. They're very challenging links to manage. Obviously, you've got nobody on the train managing it. It's got to automatically recover from any situation, not have big gaps. All of those nice things. Do remember to set your socket timeouts. That's not a good one to get wrong. Another thing on time, just as a little aside, is we're going to be bringing this together with partner data on cloud. The key we're using for that is time, on-vehicle time. That must be closely synchronized between our kit and all of our partners' kit. That's a really strong fundamental. If we get that wrong, it won't work. People always leave that to last, and it's one of the fundamentals. Another thing kind of to do with time, we've got lots of different data streams coming up. We've got different amounts of compute generating those streams, different processes generating those streams. So each of those streams runs at very different patterns of latency. You are really, in the cloud end, where you're receiving this into your big bucket of data, you're getting a very ragged edge in terms of time, in terms of what's made it up off the vehicle. And so you've got to be very careful to only compute up to the earliest edge of your data that you've received on the slowest stream at the time. I think this is the settling tank. You've got to allow that data to settle before you process it. Otherwise, you might have gaps, you might miss things. And another really important bit is make sure within each stream the order is the same. Otherwise, you get all kinds of nightmares. Another challenge we have, and this is really your sort of Scylla and Charybdis of data transfer over unreliable links. There are situations where transfers fail. That does happen. There are situations where neither side notices the transfer has failed. That's real, can't do much about those. But there are often situations where, for example, the client thinks it's failed, but it's actually succeeded, because it was just the acknowledgement part that didn't make it back. So ways to solve that: you put a unique ID on each transfer, and at the server side, you make sure you dump anything you've seen before. UUIDs are your friend. Also, uploads can apparently succeed from the client's point of view, so it's finished, it's done, but they don't make it completely into the server because it doesn't complete the transaction or whatever it is. You can, with diligent work by all the cloud people here, know all kinds of things. You've seen the DVAs, know all kinds of things you can do to try and solve these problems. You can narrow the gap down, but you can never absolutely get rid of it. So in the end, you err to dropping because it is better to drop than to duplicate. So, that was the techie cloud bit. Now we're back to pretty pictures again for my marketing friends. So now this is we've solved this problem for our customers. The customers can now get enough accuracy on the labeling of their condition data so that at each point they can say what is a progression of values at that point. This allows you to do predictive maintenance. And in the rail industry, where getting the fault in the wrong place or not noticing the fault before it actually happens and then having to close that railway line segment for half a day, the amount of money you lose in any of these situations is stratospheric. So they're very keen on running predictive maintenance. And they want to be able to reason about how their infrastructure changes over time. Now, on our side of things, we've built a map of visual features of the railway, a visual map of the whole railway system as we do this. We've got one use case, obviously. The measurement data mapping is what I've been talking about. But there are actually other things you can do with that data once you've got it sitting there in your cloud platform. One, which I'll talk about slightly more in a moment, is you can use it to bring your track workers out to the right point on the track. It's not just trains who can be plugged into this system. You can plug your actual maintenance activities in, and also more future-looking, where your robots start walking around the railway doing your maintenance, all driven from the same model of the railway. I said we didn't want to worry about latency, but actually you can start doing latency requiring activities on vehicle if you start feeding subsets of your model back to the vehicle and looking at using it on the vehicle. to generate real-time events on the vehicle. That's something you can use. We've got one thing going on with Deutsche Bahn where they want to use it to photograph where faults have been detected by the measurement trains. So the little maplet that will come back will be where the fault was detected on the measurement train. The photographing vehicle runs that maplet. Whenever it recognizes it as it passes, off goes the camera. That starts feeding towards on-train positioning. That's a bit further in the future to do that properly with this sort of a system. More fundamentally, the value of data, I think was mentioned earlier. We can start feeding this back to our rail industry customers as a product. This, as a startup, that's quite an exciting little picture. And it's a little bit far off down the line just now, but it's a nice one to do. And who knows whatever else. Let's have a quick deeper dive into one of those cases, which is, there are very good reasons to have fewer people on the railway. It's a really unforgiving environment. I'm doing some of the work we've been doing. I've been walked across live railway lines with Deutsche Bahn people with me by the scruff of the neck to keep me safe. But it's an environment where lots of things can go wrong really quickly. It would be good to reduce that. So we want workers to go to the right place first time. Our mapping allows that because they can have a mobile app in their hand, which they scan the rail beside them, matches back into our model of the railway and tells them, no, you're 10 metres out, walk 10 metres in that direction. Yes, this is a line you should be on. No, that you're on the wrong line, get off it now. All of those useful bits of information for the guy. If you're in an orange suit, if the train's coming 150 miles per hour, you really don't want to be on the wrong line still. So we save waste and we improve safety. Also, it allows verification. We can close the loop. The worker scanned the right bit of the track with his app. He has actually checked the fault at the right location. It's amazing how many times track workers go out and don't do that. Moving on, it might not just be people. You've got in future, lots of future worlds where it's going to be robots doing a lot of this stuff. They need exactly the same sort of inputs so they can navigate around, do the weld at the right place, come navigate back off again, do everything in the right place. That's something else we're working with Network Rail on this year. So I think I've probably gone a bit faster than some of the others, but hopefully that was all right in terms of timing.
Absolutely.
And we are doing this now in the UK and in Germany with various partners, and we're a small Edinburgh startup growing a business here. So thank you very much for listening.